can adjust it if you want.
Yeah, you're whatever you need.
No, I'm good. I just don't know if you need to.
Wow, okay. There we go.
Sorry, we were sitting in Rome
all
like
good.
chumps.
Nice. Yeah, they moved me over here. This is a nice room.
Yeah.
So, okay, cool. So, Ricardian model. Let's just start with like, what is the Ricardian model? What are like the defining characteristics of the Ricardian model? What do we have here? How many? I guess I'll just go through in a nice little line here. How many countries are we dealing with?
2.
Yeah. We have 2 countries.
So far away.
How many goods are we dealing with in Ricardo?
2.
Yeah, also 2 goods here. And how many inputs?
1.
Yeah, exactly. So this is the key of, one Ricardo, 1 good, or one input. Yep, there's just 1 input, and then what's the other? Oh yeah, and then how do we produce the different good? Yeah, so I mean, the comparative advantage is a word that we'll look for eventually here, but not quite. So there's two factors. There's 2 production factors, right? This one's a little bit fuzzier, but these are these are essentially like technology. And you may remember them as, I think, being denoted as like A, right, in the Ricardian model. I want to make sure I'm telling you the right direction.
That's called the unit labor cost.
Yeah. So these, they're technology. So before we get into that, yeah, it's essentially, how many? I'm going to call it the unit input cost. So how many units of input are required to get 1 unit of output, right? Units input per unit of output, right? And so there's actually 2 different ways to look at this, right? So you've got units of input per unit of output. You could also be given in the question, you could be given units of output per unit of input, right? And so this is kind of a key distinction that you'll have to determine when you get into the question. Are you given, so for example, we could say that it requires 2 units of labor to produce 1 widget, or we could say that we get 1/2 of a widget for every unit of labor that we input. Does that distinction make sense? Yeah. Input per output or output per input. And so basically the only thing this matters, if you guys remember back to your midterm, a number of people, I think the answer was like, the answer was like 1/5 or something, and they gave an answer of 5/1. And so you're just gonna have to be careful, you're just gonna have to make sure that you're like being very careful whether you're given units of input per unit of output or units of output per unit of input. And as we get into a specific question, we'll do an example question, and we'll discuss where that comes up. But really the key parts of the Ricardian model are these. This is what separates it from other models, from Heckscher, Lin, and specific factors. The key difference being that there's only one input in the Ricardian model. So there's only labor. So I mean, this could be labor, or it could be capital. I guess, or it could be land. Although we don't usually. It'll be one of those two things. But again, I mean, it could be any, like it could be land, it could be, I don't know, any other number of input, but it'll probably be labor or capital, most likely labor, because that's what countries kind of naturally have. Capital. So what does that mean then? Do you guys remember, I guess, what are some of the strengths of the Ricardian model? Or what do you guys, I mean, just looking at this, what's like something that, why do we use the Ricardian model? Nowhere in the world has only one input. Most goods require multiple different inputs, different types of production.
It simplifies the system
Yeah.
so we can see comparative advantage.
Yeah, that's exactly right. So the most important part is that it's simple. It's like an easy conceptual framework and allows us to find comparative advantage. It allows us to find comparative advantage easily, and then it allows us to very easily understand terms of trade. Right? So it allows us to really easily understand under what conditions two countries will trade just a single good. Right? So this is like why we use the Ricardian model. So if you guys are given a Ricardian model question on the final exam, that should immediately make you think, okay, I'm going to need to find comparative advantage. This is the key first step to a well-solved Ricardian model question. And then ultimately, you're most likely going to be looking for what the terms of trade are, which in this case is generally defined by price ratios. Right? This should seem a little bit familiar. So Ricardian model, first thing you're going to end up doing is finding comparative advantage. Second thing you're going to do is you're going to determine price ratios. That's like basically the structure of a Ricardian model problem is those two things. So before we get into a specific example, so these are the upsides. What are the downsides of the Ricardian model? And actually, I guess specifically, there's like one major downside to the Ricardian model versus Heckscher-Ohlin or specific factors.
Does it assume factors of production are completely mobile?
Yes, that is one thing that it assumes. Well, they're completely mobile between industries. Yeah. Well, not completely mobile because you have different unit factor costs. So like, in one industry it might cost one labor, and in another to produce one unit, and the other one it might cost 2 units of labor. But yeah, the labor can move between the two industries. That's correct. But there's complete mobility. So who gains from trade in the Ricardian model?
Both.
The reach sector.
Rich, well, there's only one input, so there's only one input sector. Yeah, so everyone benefits in the Ricardian model, right? So everyone benefits as long as trade occurs. Everyone benefits. So I would say that's like the biggest thing that the Ricardian model is missing, is that the Ricardian model has no distributional consequences, right? So there's no losers from trade in the Ricardian model. Everyone's just better off. The world is perfect. So everyone is just better off. There's no because there's only labor, only owners of labor. or owners of capital. And as you said, those the labor and capital are completely mobile between sectors. That means there's no like winner for good A focused capital, or sorry, for labor that's producing one of the goods and not the other good, because they're completely mobile. Does that make sense? So yeah, okay, good. So there's essentially no, so I guess I'll just write this down just to be really clear. No there's no distributional consequences. And that is very different from Heckscher-Ohlin and specific factors, where you'll find that we do things like calculate real wage changes in real wages, because Heckscher-Ohlin and specific factors build in the possibility of distributional consequences. So if there being some people who are not necessarily better off from trade. Okay, cool. So we'll do a just general setup of a question here, and then we'll solve it, and that will be our reminder of how to do a a Ricardian model question. Any questions about what I just went over? Okay, cool. So, like I said, we've got two countries. We'll go again. We've got Rome, and we've got Nizza. We'll have our two goods, and because I don't know, not feeling very creative, we'll have our two goods be bread and cheese. And we'll have our one input. We'll have our input be labor. Right? So if I give you, so here's what we'll do. We'll say in Rome, and Nizza. So in Rome, we have, let's see here, yeah. Is that right? Just a second. No. Okay, in Rome, we've got, let's say we've got 100 units of labor. In Nizza, we've got 50. Is that how I want to set this one up? Actually, you know what? Yeah, it is how I want to set this up. Okay. And then we've got we've got our two goods, bread, which is B, and cheese, which is C. So in one of our countries, we're going to have bread equal 2. Hey, Kayla.
Hey, how's it going?
Good, how are you?
I think there's like a fire at DuPont Station.
Really?
Yeah. It's so late.
You're welcome. So we're just going over the Ricardian model. Just a really quick recap. Key points of the Ricardian model: 2 countries, 2 goods, only 1 input. This is the key differentiator for the Ricardian model. There's only 1 input into your products, and that input will have 2 kind of production factors, or A. Good. So we got A, L, or LL, and then over here we're gonna do ALC. You know what? Yeah, actually, okay, this is how I want to do it. Okay. ALC 1, ALB also 1. Right? Okay, so here is our scenario. And so first thing we need to do, so like I mentioned, we're going to want to look for comparative advantage. I think if you're faced with a question like this, this is how I want to end up doing this. Sorry, actually, we're gonna set this up a little bit differently. Actually, no, I won't. Okay, let me see here. Okay. So I think the easiest way when you're doing a Ricardian model, for me, the first thing that I like to do is draw my production possibility frontiers, right? So if this is our PPF for Rome, and we put our quantity of goods C here, quantity cheese, and quantity bread. How do we draw out this PPF? Right, we want to get our two intercepts. So what's going to be our intercept over here on the QC side? What's our y-intercept? So okay, so we've got this. This is like this is the foundation of what we need to solve this question. So how do I go about solving this? What would I do first if I've said that what I want to do is draw a PPF?
100 divided by.
No, not quite. So actually, I guess let me define this. And so this is the key. This is why it's key. I'm going to say, so units of 2 units labor per unit of bread. And then over here, per unit of bread. Right, okay, so what are my, let's start with the C side. So yeah, 10, right? So yes, that is correct. Right? And so why is it 10? Why 10?
100 divided by 10.
Yeah, right? So we've got 100 units of labor to use, and it takes 10 units of labor to produce each item. So this is going to be 10. What if I told you that rather than being 10 units of labor per unit of bread, so rather than being the amount of labor that I need to produce a single unit, what if it was the productivity? What if I gave you instead, if I said this was the productivity of a single unit of labor? What if I said that this instead
Was MPL.
Yeah, was MPL, was the marginal product of labor. So, labor per bread. If I said instead that my marginal product of labor equaled 10.
So, Kira, would we still have that labeled as ALC when we got marginal?
Oh, sorry, this is bread. No, yeah, I shouldn't have changed that to bread. It's cheese.
That's true, but what I mean is, if we're having this represent marginal productivity of labor, is this still labeled as ALC?
Technically no, because I believe ALC would be units of labor per unit of cheese, whereas this one would be, if I said 10 units of cheese per unit of labor. But what I would encourage all of you to do is to actually just ignore this ALB, ALC stuff and just look at this, right? Which one are we, because then you don't have to get caught up in, is A the same as MPL or is 1 over A MPL? You should just look at, are we talking about units of input per unit of output, or are we talking about units of output per unit of input? So I would strongly encourage everyone, even if you are going to look at this, like A equals 1 over MPL, even if you are going to like keep this in mind, look at this. Definitely look at this, because this one, and even I get confused. I always forget whether it's that way or if just A equals MPL. I consistently just like can't remember. Highly recommend just look at your units that you're dealing with, at least as a way to confirm whether you're doing it the right way. Right? Does that make sense? Okay. But yes. So if I had given you, instead of ALC, if I had given you MPLC equals 10 units of cheese per unit of labor, then this quantity C would be how much? Yeah, it'd be 1,000 instead, right? Okay, cool. But I've given you I've given you this, units of I've given you this. So, yeah, that is correct. This becomes 10. And how much, what about over here? 50. Mm-hmm. Yeah, 50. Good. How else, what about I guess there's one other thing that would be good to write here is just the overall equation for this PPF. How would I write just this equation for this PPF?
The price ratio?
No, not quite. Generally, you might be given a setup like this. I guess this isn't super important to. So you might be given a setup like this. You could also be given something like this, where it's like Rome's PPF is, it would be, well, if we used, well, how would this be? It would be amount of labor. No, not amount of labor, right? Because we know that our total labor, L bar, equals L sub B plus L sub C. And we know also that if we do this, so we could get 1 over A times L B, right? This is the amount of output you produced plus right, this should be, let me make sure we've done this right. I want to make sure I'm giving you guys the right equation here. If we do, oh, okay, sorry, that is why, that's quantity. Yeah, that's why I am doing this wrong. Sorry. Just want to make sure, okay, so A L B times B plus right, so this should be our generalized form for our PPF, let me just make sure that that is actually right. If I took 2 times 50, yeah, that would give us 100. Okay, good, yeah. So this is our generalized form for a PPF.
Why is the capital letter A?
Oh, just because I wrote it like capital
Same
letter.
thing.
Yeah.
Okay.
Right? So we could see this. So this this equation for Rome would end up being 100 equals 2 times B plus 10 times C. Right? So you could be given this PPF form and you say, oh, okay, well, right away, I know here, Rome, we've got 100 units of labor, and we've got a ALB of 2 and an ALC of 10, right? So you could be given both of these ways of writing your equation. So then Nitsa's is going to be 50 equals B plus C. So how does my PPF for Nitsa look? $50 and $50. Okay, so we've got this now. So what's the first thing? What do we want to find? Why did we draw our PPFs? As I've said, the first thing, or like what we're trying to get towards, is finding comparative advantage. The reason is that I like to find the slope. Slope is going to be -1/5 here, and -1 here. What is this slope? And so I guess the first thing, when we're looking at slope, technically the slope is a negative number, but as soon as we start talking about it, you can kind of just ignore the negative number or the negative sign. It's not super important for our purposes here. So what does this slope tell us? This is the key. I think this is the key.
Opportunity cost.
Yeah, opportunity cost of, you got a 50-50 shot?
Bread in terms of cheese.
Yeah, that is exactly right. Opportunity cost of bread in terms of cheese, right? So 1/5, this is the opportunity cost of bread in terms of cheese. So what is that? So key point here, your slope of your PPF is the opportunity cost of your x-axis good in terms of your y-axis good. So PPF slope equals opportunity cost of x-axis good in terms of your y-axis good. Right, so this is key. This is like the most important, I think. This is the most important like thing that you get. This is the most important step in the Ricardian model. So if you can accurately draw your PPF, you've basically solved the Ricardian problem at this point, right? So that means, just again, be really sure about whether you're talking input per output or output per input, right? Key. Okay, so we've got our slope, so opportunity cost. So we've said that that's our opportunity cost of bread in terms of cheese. So what does that mean? What does that mean? So I've now said my opportunity cost of bread in terms of cheese in Rome is 1/5. So what is this? Can someone tell me like what that means, just in other words?
It'll cost you 5 loaves of bread for 1 piece of cheese.
Yep, 5 loaves of bread for 1 piece of cheese, or 1/5 of a piece of cheese for 1 loaf of bread. So technically, this number, which we've said is bread in terms of cheese. So this number specifically, 1/5, is how much of your y-axis good you need to give up to get 1 unit of your x-axis good. But yeah, then if you take the inverse of it, so 5, that's the number of your x-axis good that you need to give up. And that should make sense. We can produce 5 more units of bread than we can of cheese with every unit of labor that we get. Any questions?
Can you quickly just write how it would look with price, like PC?
Yep, so we're getting there shortly. So we've said our opportunity cost. Yeah, so we've said it. Well, so actually, I guess let's think about this. So in this country, so let's go with Rome because we have different price or different costs. What are we gonna find here in terms of price? Which good is gonna be more expensive in Rome? Why?
Less productive.
Yeah, so cheese is going to be relatively more expensive in Rome than it's going to be in, cheese is going to be relatively more expensive than bread. And even if we're just looking at this should make sense because 1 unit of labor, and remember, this is just labor. So like, if I'm like an owner of labor, the amount of money I'm going to get per hour theoretically is going to be the same. My wage is going to be the same whether I'm working in bread or in cheese, in the bread or the cheese industry. So, but because in the cheese industry they need a lot more labor to produce the same amount of to produce the same unit quantity, cheese is going to be more expensive. Basically, whichever one they're able to produce less of in autarky, that's the one that's going to be more expensive. Right? Because it's harder to make it. We can see it right here. It's harder to make cheese than it is to make bread. So that should, that's the next step. After you figure out the slope, just intuitively, whichever good a specific country is able to make less of, that good is going to be more expensive. So we can look here, right? And we can say, we can also say in terms of pricing, we can say that ALC over ALB equals PC over PB. Right? So, and this is key, ALC. So you got it, if you're doing it this way, you have to keep the same numerator. So you've got C on both sides. So this should make sense. We would have 10 over 2 equals the price ratio. So we would end up with a price ratio of 5. So, right? So price ratio. So what we're saying here is that cheese is 5 times more expensive than bread in this economy. That should make sense because cheese is 5 times more difficult to make. It takes 5 times the amount of labor to make 1 unit of cheese as it does to make 1 unit of bread. Does that make sense? So just to reiterate that, your A ratio is equal to your price ratio. But again, that's units of labor per unit of, it's units of input per output. Input per output equals the price ratio. You should just also, just look here, right? Whichever good has more production. So, you can just take your ratio. So the other way to find this price ratio would be to take the ratio of these two numbers. So you would say PC over PB equals QB bar over QC bar. Right? Bar meaning the maximum amount. 50 over 10. Make sense? Yeah, so good. So that was a good question. So what we said here we've said the opportunity cost of bread, so it's bread in terms of cheese. So in Rome, opportunity cost of bread is going to be 1/5 of a unit of cheese. In Nizza, it's going to be 1 unit of cheese. So now we can go ahead and answer our key question. Which country has comparative advantage? So let's start here with, let's do CA. Who's got comparative advantage in bread? Who remembers how to calculate, how to find comparative advantage?
A divided by
Uh-huh.
A bread divided by A.
Yeah, and then what?
And then the bigger one is advantage.
So which one has advantage in B?
Should be needs.
Should be wrong.
Yeah? Rome. It's Rome.
Oh,
Rome should have the comparative advantage in bread production. So, and why is that the case? Right? So let's take a hard think about that one. So we've said Rome has the comparative advantage in bread, and here's why. Rome has to give up 1/5 of a unit of bread in order to make a unit of cheese, whereas Nizza has to give up a whole unit of bread in order to make a unit of cheese. So Rome has the lower opportunity cost. Rome has a smaller opportunity cost for making bread. That means that they have the comparative advantage in bread. Nizza, on the other hand, so if we think about now our comparative advantage for cheese, what are our opportunity costs for cheese? In Nizza, it's still 1 unit of bread for 1 unit of cheese. In Rome, though, if we're now thinking of cheese in terms of bread, it becomes 5. The opportunity cost is 5. 1 is less than 5. And so the comparative advantage goes to Nizza. So again, see, the comparative advantage goes to country with lower cost of that good. Right? So again, so this just to reiterate, and this I guess is so whichever country has the lower opportunity cost for that good, that's the country that has the comparative advantage. So Rome had a lower opportunity cost, 1/5 versus 1 for bread. That means they got the comparative advantage for bread. Nizza had the lower opportunity cost for cheese, 1 versus 5. So they have the opportunity cost or comparative advantage for cheese.
Now, just to think about it, so I'm framing it properly. It's,
Yep.
The comparative advantage to get 1 more unit of bread, you give up 1/5 of cheese.
Yes.
And so the opportunity cost is what you're trying to get. Like to get 1 more unit of bread, you're giving up 1/5 of cheese.
Yeah.
Okay.
Yeah, it means that, but the other way to think about it is that if you make another unit of bread, if you make one more, if you're making one more unit, if you're making 1 more unit of bread, then you're only giving up 1/5 of a unit of cheese. There's not much to give up. The other way to think about it was if you want to make more cheese in Rome, you have to give up a lot of bread, right? You have to give up 5 units of bread to make 1 more unit of cheese, which means you're losing a lot more bread. Your opportunity cost in bread is higher. Yeah, good question. Any other questions about this? So comparative advantage, the other way to write it down, since we said, so you would, if you take the ratio ALB over ALC versus ALB star, and in this case star being NHTSA, over ALC star, right? So if we look at this, this is going to be 2 over 10, and this is going to be 1 over 1. So the other way you can think about it, if we're just dealing with like just A, if they've just given us A, is that the country with the comparative advantage, if you do a ratio of the A's, comparative advantage is going to be whichever country is, whichever ratio is smaller, that country's gonna have the comparative advantage in the numerator good. So if we do it like this and we're saying which one's smaller, you're gonna be testing, the smaller one is gonna be the numerator good, is gonna have comparative advantage in the numerator good, B, and whichever one's larger is gonna have comparative advantage in the denominator good. So a whole bunch of different ways to find this. I think the best way is to draw the PPF. It doesn't take very much time. In this, we've taken a little bit of time, but it doesn't take very much time, and it's the way that I think you're most likely to not make a mistake, because you have this nice visual here that tells you, exactly what's going on. So we just talked about comparative advantage. How about absolute advantage? Let's just do absolute advantage really quickly. So who has the absolute advantage in producing cheese? Why? Yeah, because the cost is lower, yeah? So we said cheese, so the cost of making cheese is 1 versus 10. So NHTSA is much better, has an absolute advantage in cheese production, How about bread production?
Also NHTSA.
Also NHTSA, yeah, good. So really key point. NHTSA, so comparative advantage, there will be, one country can't have comparative advantage in both goods. One country can have absolute advantage in both goods. And absolute advantage is based on the unit costs, not the overall, right? Because you could say, well, it's not the case in this scenario, but you could imagine if I said NHTSA has 5,000 people in it. Actually, I guess, no, sorry. Not NHTSA has 5,000. I could say that Rome has 10,000 people, and now the total quantity they can produce of both goods is much higher than what NHTSA can produce. But for absolute advantage, we're only worried about unit costs, not overall productive capability. Does that make sense? So absolute advantage, unit costs only. One other key point here, I think this was on the midterm, who knows if it'll be on the final, but what are we looking at in terms of wages in these two countries, theoretically? What are wages tied to? Yeah, tied to price, sort of, yeah, price ratio. So where are wages gonna be higher? Yeah, they're gonna be higher in NHTSA, because, and it's not so much, they are tied to price, so that's an indirect tie. I would say the more accurate way of thinking about it is wages are tied to productivity, right? And what we can see here is that workers in NHTSA are significantly more productive on an individual basis than workers are in Rome. Because again, it just takes one worker to make a unit of bread, whereas it takes in NHTSA, whereas it takes 2 workers to make a unit of bread. So they're more productive. Whoever's got higher productivity, those wages are going to be higher on an individual level.
So when we're assessing wages, are we just looking at absolute advantage?
So, I mean, essentially, yes. Yes, absolute advantage gives you the wages. And again, that's just like absolute advantage is a per unit absolute advantage. So like whichever one costs less per unit, not like whoever can produce more. When we're talking about wages here, this is like individual wages, not like aggregate wages. Because again, one country might have like a bajillion more people, and even if those people are paid less, it might still have like higher aggregate GDP. But for wages, we're talking specifically about individual wages.
What if you're like more productive in one good and then someone's more productive in the other good? Then would it have to just be like relative?
Yeah.
Okay. So like
It would
would be higher in cheese relative to bread, and then like the opposite for the other country. Does that question make sense?
No, I see what you're saying. To be honest, I'm actually not sure.
Okay.
Yeah, I'm actually not positive. I don't think you'll encounter that scenario. You didn't on the midterm. Because wages equalize within country. I think you'd still try to look at which country can in general produce more quantity of goods per unit. But yeah, I would say let's not worry right now about if there's different absolute advantages. Or we'd say, I guess, yeah, wages in one sector would be higher. It's not that individual wages. I wouldn't worry about that, basically. Sorry, I can't answer
Maybe
that.
it would depend on their consumption.
Yeah, it would probably depend on consumption patterns, yes. Okay, so we have one more piece here. So what we've said is we've calculated out our different price ratios. So PC over PB is 5 here. We know PC over PB star is 1, 1 over 1. So what, I'm gonna actually go ahead and erase this piece over here. Yeah, I'll erase this piece. So what do we need to find now? So I said the first thing that we try to find with a Ricardian model is comparative advantage, which we just determined. It's whichever one has the smaller A ratio or the smaller opportunity cost on your slope, or with the smaller slope. So we found price ratio, or sorry, we found our opportunity costs and comparative advantage. So now we need to find the terms of trade. So this will be the next piece. So what do we need to find for terms of trade? And this should bring back memories of what I'm assuming is everyone's second favorite graphical model from this course, which would be this lovely step item here. Okay, so we've got our global relative supply curve. So let's label all of our axes, because we're thorough in this way. What do we label our y-axis? Yeah, price ratio. Yeah, but what price ratio? Huh? PC over PB. Why did you pick PC over PB? Good, yeah. You should always pick, because you could do PC over PB, or you could do PB over PC. You should always pick the one that matches the work you've already done, because that's easier for yourself. So yes, that is the correct answer. Price, it's going to be price ratio. How about our x-axis?
All PB.
Relative quantity supply. Yeah, relative quantity supplied. Global relative supply, I believe is the official term. But yeah, it's the quantity ratio. And so in this one, we're gonna do QC plus QC star over QB plus QB star. Right, this is just the total amount that's being produced in the world. Good. So what do we end up with? So what are we've got 3 different numbers that we're looking for. We're looking for this number right here. We're looking for this number right here. And we're looking for this number right here. So let's start up here. What is this vertical number, the top one? Y. Okay, well, so what did we just say was the relationship between, well, so what, I guess, did we calculate our price ratios for our 2 countries? So what did we come up with? We had here, PC star over PB star equals 1. What did PC over PB equal here? Was it 5? Was it not?
Which one?
Yeah, it was 5. Good. So it's 5. So now, what do we put? Which one do we put up top? Yeah, good. Yeah. So don't make it too complicated on yourselves. Once you've got your price ratios set up in the same order as this one, just pick the higher one. Put it there, and then you can put the lower one here. Right? So the key, but I mean, we laugh, but like the key here is you could have done PB over PC, in which case your top number would be 1 and your bottom number would be 1/5. Right? So I mean, it's kind of simple, but straight, but like, you know, obviously you got to make sure that you're doing, that you're maintaining the same PC over PB that you're doing, that you have over here. Good, so we've got 5, we've got 1, and then what do we have? What's this over here? What happens? So we're basically asking what are the terms of trade. So that means what is the, between what prices our countries, do the relative prices have to fall? So I guess actually we should make this explicit. So we should say 1 is less than PC over PB is less than 5. Less than or equal to. Or 1/5. Right? These are the same. So what we're saying is that if the world relative price falls between those numbers, countries are willing to trade. So in the Ricardian model, what happens during trade? I guess this is another key point. What happens during trade in the Ricardian model?
The country with a comparative advantage produces all of it.
Yeah, exactly. So countries specialize in trade, and we usually see complete. I mean, so it will, with the caveat that it does ultimately depend on what global demand looks like. In general, in the Ricardian model, we see complete specialization. So, with that in mind, what's my number down here gonna be? Can we solve it? Can we get a specific number here?
Yes.
Yeah, so what would it be? Are we gonna take QC or QC star from the numerator? Why?
Because of the focus.
Yeah, good. So we know that for cheese, NHTSA is going to be producing our cheese because they have the comparative advantage in cheese. So we're going to do QC star over QB is going to be our solution here, which is going to equal how much QC star are they going to produce?
50.
Yeah. And over?
50.
Yep, 50. So they're actually going to end up producing a relative total of 1. They're going to produce 1 to 1. So in this economy, in trade, in specialization, they're going to produce an equal amount of these goods. Right? And so you could, if you're given, I guess one other thing, you could be given a demand curve here. The only other thing you could potentially need to do is solve for like the actual PC over PB world price, right? And so if you're given a demand curve that has a global demand, you can set that equal to 1. You could solve it. You could set it equal to your ratio here, and then you could solve it out. So any questions on the Ricardian model? Again, just to like emphasize the key points here, Ricardian model only has one input with two unit factor productivity measures. So that's generally going to be labor for your one input plus like A sub L, and A sub L good 1 and A sub L good 2. The main pro of using the Ricardian model is it's quite simple and it lets you easily map terms of trade. The downside is it doesn't allow for distributional consequences. The key parts here is that you need to I would start by building your PPF, then from your PPF determine your slopes, your opportunity costs. From your opportunity costs, go to comparative advantage. From there, build your terms of trade marker here, and then you can build out your world relative supply and relative demand if you need to. So yeah, any questions about Ricardo? I guess we'll do Hexrolin next time. Let's do that one in formal. We'll do it a little bit quicker. Okay, so I mean, just a couple other things I want you guys to think about. What are the different things that can happen in a Hexrolin world, or sorry, in a Ricardian world? There's really only a couple of different ways that he can different things that he can throw at you in a problem. One, he can change the total amount of labor that exists in your country. Will changing the total amount of labor have any impact on what we just did?
The Q will change.
Yeah, so total quantities here will change, but no ratios will change, right? So actually changing the amount of labor really only changes total quantities. It won't change, if there's a labor shock within the Ricardian model, you're not gonna actually see any changes to your answers, because these are all based on relatives, and your quantity of labor that you own, your quantity of your input, is actually not super important for solving out the Ricardian model. What that means is that really the only things you can actually really do in a Ricardian model to kind of shake things up a little bit is shocks to your unit factor productivity, which will generally come in the form of a technology change. So you could think of in NHTSA, maybe we'll go with Rome because their technology is shitty. So maybe Rome figures out how to improve their bread making capabilities. So this goes down to 1. Or maybe you could also maybe half of Rome's cows die from the mad cow disease. So now they have a lot less cows, and that makes their productivity, that essentially makes their productivity in their cheese sector, their labor productivity, like decrease a lot. So this could go up. So those are really the only changes you can have. So if you're wondering beyond this like basic framework about how to think about the Ricardian model, I would encourage you to just go through and just think about, or like have a little think about what happens when there are shocks to your A values, because that's really all you can do with a Ricardian model problem. Okay, cool. I will see you guys on Friday. We'll probably end up needing to do an hour and a half on Friday, just because I'll try to go a little faster at the beginning, but this took a full hour for one model.